Okay, so in this next part of these unit testing demos, I'd like to show you another feature of xUnit. So far, all of our tests have had the fact attribute on them. But there's another kind of test called a theory test, and that's what I'm going to show you now. So far, when we do a calculation using the calculator class, we're specifically calling the methods we want for each operation type. Want to add two numbers? Call add. Want to divide? Call divide. But I know that I'd eventually like to use the calculator from a user interface, and I'd like to introduce a method called calculate. And this method will be able to trigger any of the calculation operators from a single method. What I want to have is a bunch of calls that look like these, where I pass in the operation type that I want, and then also pass in the value1 and value2 arg values. I could do this with the fact attribute. All I'd have to do is create a fact test method for each case. In the case of this calculator demo, that probably wouldn't be that bad. But in real-life coding, when you have a bunch of different test data that you want to push through the same code, it gets repetitive. It's annoying, and you can end up with a bunch of duplicate code, which can be tough to maintain. This is where theory tests come in. The theory attribute indicates to the xUnit test runner that there's a test to run just like the fact attribute does. Fact tests work alone, but the theory test attribute works in conjunction with the InlineData attribute. The InlineData attribute lets you specify the test data that you want to use in your test. Before I start populating those InlineData attributes, let me sketch out the test method so it's a little easier to understand. I'll create a calculate method that returns void and takes a bunch of arguments. A string arg named operation, then int args for value1, value2, and expected. And you end up with a method that looks like this. Now let's plug the data values into the InlineData attributes. The first one will be for the add. The order of the values in the attribute need to match up with the order of the parameters on the method. The first item will be a string that says add, then the int values. Then I'll add an InlineData attribute for each additional case we want to run. An attribute for the subtract case, then the multiply case, and finally the divide case. In the arrange, we'll create an instance of system under test. Then we'll do the act portion of the test. I'll declare an int variable named actual to capture the result. Then I'll make a call to the calculate method. I'll pass the parameter values for operation, value1 and value2, and then that result gets stored in actual. And finally the assert portion, assert equal expected actual, and that's pretty much it for the test code. I just quickly create the basic method implementation in the calculator class using the quick fix menu. This will probably compile, so I think we're ready to run the test. Click refresh in the test runner. And now we see the calculate test, and under that parent test, a bunch of subtests, one for each InlineData attribute. So what the theory attribute does is allow us to run the same test code multiple times with different data that gets passed in using the InlineData attributes. It's super handy. I use this kind of stuff all the time. It's especially helpful for input validation. Let's run the tests. Click run all, and the theory tests all run individually. Of course, they're all failing because there's no implementation yet and we're throwing a not implemented exception. Let's create that implementation. And rather than have you watch me type, I'm just going to paste it in to save time. And here's what we end up with. It's basically an if-else block that checks the operation string and then calls one of the calculation methods. I'll run the tests, and they should all pass, and they do. Just for fun, let's check on our code coverage. And we've gone backwards a little bit on code coverage, and the cause of the problem is line 52 in the calculator class. We're not exercising the error handling for when there's an unknown operation. To get us back up to 100% coverage, I'm going to paste in a couple of additional tests. Here are those two additional tests, a calculate divide by zero test and a calculate throws on unknown operation test. Both of these use assert throws to validate the expected exceptions. Let's rerun the tests with coverage. First I'll refresh and run the tests, and well, we're getting an exception in the unknown operation test case. Assert throws failure because exception type was not an exact match. Expected an invalid operation exception and got an argument out of range exception. That's just an error in the test. Basically, the assert throws statement has the wrong exception type that it's checking for. I'll just quickly fix that. Change that generic argument to be an argument out of range exception. Rerun the test, and this time they pass. Commit these changes to version control. All right, so that's the demo of using the xUnit theory attribute to create data-driven tests. In the next demo, I'll show you how to use your unit test suite to refactor your code with the goal of eliminating duplicate code and keeping everything clean. Stay tuned.